All right, hello again and welcome guys to G Squared Academy, where you know excellence is invariably epitomized. In today's video, what we're going to be doing is a paper 3, and this one is taken from May-June 2015. I think this is the January paper 2015, right? And of course, as you can see on the screen there, it's an alternative to the SBA for those people who need to do that. And you also need to remember that in 2015, the syllabus changed. So some things were removed from the syllabus. I don't think anything really was added, but mostly things were removed from it. So let's get right to it. Just wanted to point that out so that you guys are aware of that. So you are required to investigate whether, and this is question 1 invariably, whether a particular sample of liquid bleach meets certain manufacturing standards. To meet these manufacturing standards, 1,000 centimeters cube of bleach should oxidize at least 0.01 moles of iron 2. You're provided with 3 solutions, A, B, C. Solution A is a potassium manganate 7, which is potassium permanganate, KMnO4, of concentration 3.2 grams per dm cube. So they've given you the mass concentration. Solution B is a 0.01 molar, so 0.01 moles per dm cube solution of iron 2. Solution C is a sample of liquid bleach, and here are the procedures. Place solution A in the burette. So they are saying the potassium permanganate here is your standard. Pipette 25 mils centimeters cube, same thing, of solution B into the conical flask. So solution B is the iron, and we know the concentration of the iron, right? So using a clean pipette, transfer 25 centimeters cube of solution C. So now you're taking the bleach and you're adding it to the conical flask which contain the iron. All right, and you mix that gently. Titrate solution A against the mixture in the conical flask until you get a faint pink color, which remains after shaking. And repeat until you have receive consistent results, but do not do more than 3 titrations. So when they say do not do more than 3 titrations, what they're really trying to say is that if you're going above 3 titrations to get your consecutive results, then that kind of speaks to your titration skills, right? Which they may mark you down for. So here you go. This is you will record your results, your initial volume, your final volume, your volume used. Okay, so that's what you do with your table here. Okay, so that's what you record your initial volume. So remember, you're supposed to read the burette. After you fill the burette, you read the burette. Okay, then you record that as your initial volume, and then after you titrate and you get your faint pink color at the end point, you record that as your final volume, and you subtract your initial volume from your final volume. Okay, so when you're finished, you should have a table which looks like this. So this is what your table should look like. I've just fabricated these numbers just for the purpose of the experiment. Okay, we're not saying that this is what you're going to get, for example. All right, so initial volume 0.10, 0.00, 0.00, final 25.5, 24.3, 25.4. So what you should recognize already is that 2 of the values are the same, and 1 of them is right there in the 24. And you need to remember that you should average your best 2 values. If you have 3 where there's a difference of 0.1 between them or among them, then you average all 3. So let's say this was 25.3 and this was 25.2 and this is 25.4. So you'd average all 3 of them. But in this case, you only have 2 here which are the same, and this one is too far off because your values should not differ by more than 0.1, plus or minus 0.1. So we would average these 2 numbers. Okay, so let's go back now to okay, see, so now we're back at the question. It asks us to calculate the average volume used in the titration and indicate in table 1 with asterisks the titrations you use. Of course, we would mark out those 2 ones. These 2 ones we'd use as an asterisk and calculate the average, which would be 25.4. All right, so now guys, we're going to push on with the questions, right? So this one over here asks us to calculate the average volume. Let me pause this. Right? So all we need to do, so that's 25.4 plus 25.4 divided by 2, and of course that works out to be 25.40, right? Centimeters cube. And you would asterisk the two boxes with those numbers. Then now it says calculate the number of moles of potassium permanganate in 1000 centimeters cube of solution. The relative molecular mass of potassium permanganate is 158. So basically they have given us everything. For us to find the molarity, which is the moles in 1000, because that's what concentration is in terms of moles, the molarity, which is capital M, is equal to the mass concentration, right, divided by the molar mass. Okay, the mass concentration was given in the question, so I'm just going to find that now for you and show you where it was given. Wrong direction, sorry. So here it is, right? The mass concentration, 3.2 grams per dm cube. So that's the mass concentration. So now we're going to put that in the equation. So that's 3.2 divided by 158. And that works out to be, right, 0.0203. And that's the molarity. That's the number of moles of potassium permanganate you have in 1000 centimeters cube of solution. So the next question says calculate the moles of potassium permanganate in the volume of solution A determined in A2 above. In other words, what's the number of moles of potassium permanganate in your average volume? So we know that there are 0.0203 moles in 1000 centimeters cube. We now want to know how much is in 25.4. So we need to now cross multiply. X is in that, we don't know. So X is going to be equal to, so X works out to be 5.14, right, times 10 to the minus 4 moles. So that's the number of moles of potassium permanganate in your 25.4 mils of sample. That's your titer volume. So let's proceed and see what else we need to calculate. So the next thing we need to calculate now is the moles of iron 2 plus, originally present in 25 mils of solution B. Remember, we pipetted 25 mils of solution B. So now they want you to calculate the moles present in that. But we need something to calculate that, which is the concentration of the iron. So I'm going back now to check for the concentration. So they gave us that the concentration was 0.1 moles per dm cube. So we can now find out how much is in 25 centimeters cube. Okay, so 0.1 is equal to 1000. So that's the number of moles in 1000. So how much would be in 25 mils now, right? So that would work out to be, and I'm just going to write the answer over here. So X would be equal to 2.5 times 10 to the minus 3 moles. Okay, that's handwriting was bad. But anyway, 2.5 times 10 to the minus 3 moles. That would be how much is present at this time in the 25 mils of iron. So now it says calculate the moles of iron 2 that reacted with the potassium permanganate during the titration. The ratio is 1 to 5. Okay, so this might be the tricky part for most people. So what you need to do here now is recognize that it's 1 kMnO4 to 5 moles of iron. So what you need to find now is the moles of KMnO4 that reacted. So we go back, right? And what we find around here is that the moles of KMnO4 in the titer volume was 5.14 times 10 to the minus 4. So we know how much moles of KMnO4 reacted with that one. So 5.14 times 10 to the minus 4. So how much of iron would that react with? X, since the ratio is 1 to 5. So all we need to do now to find the moles of iron is to multiply by 5, right? So that's 5.14 times 10 to the minus 4 times 5, and that works out to be 2.57. 2.57 times 10 to the minus 3 moles. So that's the number of moles of iron that was reacted with the potassium permanganate. 2.57 times 10 to the minus 3 moles. So the next part of the calculation says calculate the moles of iron which reacts with 25 centimeters cube of solution C. Okay, so we now need to find out how much reacts with solution. Okay, so now you're being asked to calculate the number of moles of iron 2 which reacts with 25 centimeters cube of solution C. Now you had an initial amount of iron 2 plus ions, right? Which is what we calculated up here in this region. That's what we calculated there. Now you're being asked to determine the number of moles that reacted with the solution C. Now the thing is that some of that original iron 2 plus would have reacted with the potassium permanganate. And what did not react with the potassium permanganate would be the amount that reacted with solution C. Now, because if you remember, I said I fabricated these numbers, right? The numbers that I got for the table, these numbers here in the table, I fabricated those. So when we do our calculation here, it would be the answer we get up here, right? Let me just get this thing going now. So it would be the answer we got up here minus the answer we get down here. The original minus the sum that reacted with the potassium permanganate. But as you can see, this is 2.5 times 10 to the minus 3, and this is 2.57 times 10 to the minus 3. So this clearly is more than what would have reacted there. But the point here is that I want to show you how to do the calculation. Remember, I'm using fabricated numbers. So therefore, it would be the answer you got here minus this answer here, and that would be in 1,000. So once you get that number of moles, that's the, sorry, not in 1,000, in 25 centimeters cube. Once you get that answer, that would be the number of moles of iron 2 plus that react with solution C in 25 mils. So all you need to do now, let's just say that the amount that reacted, that was left back, was 0.7 times 10 to the minus 3 moles. Let's just say that. That would be in 25 centimeters cube of solution. Okay, now they're asking you to calculate how much is in 1,000. So all you need to say is 0.7 times 10 to the minus 3 is in 25. So how much is in 1,000, right? Let's call that X, whatever number that is. Okay, so we're gonna call that X. Okay, now when you get your answer here now, your examiner now says you should determine, see, does the solution meet the required standard? So based on the answer you get there, you now need to determine if it meets the required standard. What's the required standard? We have to go back a bit. The required standard is that to meet these manufacturing standards, 1,000 centimeters cube of bleach should oxidize at least 0.01 moles of iron 2. So when we get to our question for the last section there, this last section, let me go back a bit, right here. If the answer we get here, of course, is less than 0.01, then it does not meet the manufacturing standards. If it's greater, then it does. All right. So this is question 1, 2015. I'm Gilly Gills, and this is G Squared Academy. All the best.